Hello, hello. Welcome at the CocoaHeadsNL Meetup at Adidas. Glad that you are all here. It's a very big crowd today, so that's fun. Hope you all enjoyed the pizza. Thank you very much for that, by the way. It was very good. I still have to look at the slides. I still don't know them by heart. But if you're new to CocoaHeads, we're a monthly meetup of iOS and Mac developers, but sometimes we also talk about other software-related topics or Android. Not today, not today. Oh, yeah, we also have sponsors to make this happen every month. Here you can see them on the slide. And of course, Adidas today is wonderful hosting us here in this nice space. I hope you're not recording me, Bart. Thank you. If you also want to be part of our nice family, then you can also get some t-shirts or sweaters if you like. But I see you guys all already are very well dressed, so go get a mug or something. Today the talks will be, both will be done by employees of Adidas. Eduardo is one of them. I also saw Rafael somewhere in the back. He will be the second one. So I hope you all enjoy it as much as we will. And if you want to do a talk in the future, then please let someone know so we can plan you in for the next meetup. And the next time, of course, very important, is WWDC. And those we will be viewing at ABN, also in Amsterdam. So please come join us if you can. And if you want to look back on previous presentations or anything, then you can just follow us on all the well-known channels. We also have an announcement for tonight, because the security will be gone from, I think, 8 till 9 o'clock. So if you want to leave by then you need to head down the elevator and go out through the car park. And otherwise, they will be back from 9 till 10. So then everything will be fine. Yeah? Good. Then I will give the microphone to Eduardo. Please, big applause.
Yeah, so I'm Eduardo. I'm originally from Brazil. I've been here for almost 3 years. And mostly I work on the Confirmed app and also with the foundation team. So what you're gonna see today is like the combined work of foundation team and the other members that we try to condense. But small disclaimer, it is a lot of text because it's not like a super simple topic. So I'm not gonna read through everything, but you see a lot of text. So if you see something that you kind of don't understand, you can come back to the slides and send us a message, we can explain and so on. Yep.
Can I please interrupt you a little bit?
Yep. The beard.
Let's try it.
Good? No? Yeah. Okay. Yeah, so let's start. So,
Eduardo, you can try
in the back. Okay. Yeah. Ah, okay. Yeah. Yeah. Okay, so to start, so like super short thing about what is a modular architecture, why do we need it, what is a module, the things we do with interfaces versus implementation modules and how this affects the dependency graph. Also a disclaimer, this will be like super quick on this point because Rafa and George will come later and explain this in a little bit more detail. And then how we separate the modules, the layers, and how everything connects for us. So basically, a modular architecture is a Lego. Like the end goal is I want to be able to connect as simple as pieces of a Lego, should be super quick, and each piece should work alone by itself, like in a self-contained part. So why? So why is, if you have like a huge team, you need to be able to develop things faster. You need to be able to isolate the modules, the features you do. You also need to be able to scale super quickly. And you need some sort of support to collaborate better with the rest of your team. And so what is a module? The module for us, like you have one example here, and we have even a high number that's gonna grow soon. We're still modularizing some things. So basically a module will have these folders, 3 folders, and let's say an idea, a concept, a target. So the first folder will be sources, all the code, resources, JSON, image, whatever is not code. The tests that may or may not exist in a module, depending on the type of the module. And those tests that will include unit, snapshot, integration, and so on. And also, sometimes we have sandbox apps. So let's say you have a small piece of the flow that you want to use in isolation. Let's say logging. You want to be able to say logging succeeded. You are able to go there and just pick that small piece, work whatever you need, instead of compiling the huge app, this 242 modules. You can just compile some of them, then it's super quick to do this change and check what's going on. So the first concept is, and again, reminder, we're going to talk more about concepts. So you're not going to see code, you're going to see folder structures, names, and ideas. Those ideas are not exactly what you see, like, if you look at clean, you're not going to see one by one what we do here. We have our interpretation on this to make sure it adapts to the reality we have in the project. So main purpose of a module that's an interface or a contract. When I say interface, it's not protocols. It's like the idea of a contract that will represent the module for the outside world. So the public APIs that shouldn't change that much. In this module, you'll see the contracts and models. And that's what you should be able to use everywhere. So, for example, analytics, you may have your own implementation of analytics, but to make your life a bit easier and help the compiler, which I will explain a bit later, instead of getting the whole like blob of analytics code, you get just the models and the method track event, for example, like super short things, super small things. And then every time you have an implementation, you will normally have the concrete, like the real materialization of that contract you're using on the other module. And this may go from, I don't know, anything, like networking, the logging flows, the analytics core itself, like the whole thing that's going to make analytics work. And one important thing about this is that it's not going to be every time that you see a module that you should expect an interface. Some modules doesn't make sense to have an interface, especially because they shouldn't change much. So your dependency injection system, for example, it probably doesn't change much. So you don't exactly need to have the interface. You can, but it's not like a super hard requirement. And now, why? Why do you need those interfaces? So, in short, Xcode is not your best friend sometimes, and when it tries to cache something, or when there's a small change, it might compile everything instead of just a small piece of change you did. So, for example, let's say you have this dependencies, and you have the HTTP client. And all those features that directly connect to the HTTP client, they depend on it. So if you go there and change this module, there's a very high possibility that Xcode is going to miss the cache and is going to compile all this you see here. So it's not going to be good in the end. So, yeah. And of course, you can say, but I use Twist, I use Buck, I use Bazel. It helps, but it's not enough. You need to do a bit of work on top of that to make it even better. So after you use these interface modules, your dependency graph will get way more horizontal, and you're not going to have like super direct dependencies. And in theory, if you don't change the interface, it shouldn't recompile. And the interface, the public interface, it shouldn't change that much. Of course, when it changes, you will recompile. But you shouldn't keep changing this. It's more common to change the core, the engine, what's behind that, than the interface. And this leads to way better, more optimized builds, and Xcode gets happy, caches better, your build system also gets better. This graph is actually something I just got from a presentation from Bruno Rocha. It's a guy that is from Spotify. I worked with him back in Brazil, and he's really good talking about this. So if you need more details about this, I think he's one of the best guys to go and talk about it. And also Rafa and George will explain our specific case on how this affected our builds and our build system in general. Yeah. Okay. So now we're going on the types of modules we have. So as we said, interface will be laying around most of those. So the first one is UI. And on the side here, you see the number of UI modules we have. You're going to see that some have the name like Adidas or Trilogy or no reference to a project. This is because we're still in the process of modularizing. So sometimes you're going to see those big blobs that should cover all cases, but they will be broken down. And a UI module, it can be super specific or super generic. Like when you have a generic UI module, it's going to have all UI-related code, or most of the UI-related code, for something that's more broad. Like, let's say, you have the extensions of UIKit, the extensions of Swift UI, or your own special flavor of doing view code, this type of things. So it doesn't have a very specific topic or domain. And then you have domain specific. So let's say you want to make your logging flows for different apps in a way that you just connect the dots. You could have a UI module that represents all the logging small pieces, like the input or the button that's very specific, so on. And then you import that in your logging experience that we're going to talk soon. And then you connect and you create the logging itself. So for example, for China here, we could say that China uses the UI components, but not the flows. And then you can just piece things together. The next one is core. Core is like a super broad name. It's super common to say, this is the core, you put everything there, and that's it. But we try to separate a little bit. And we're still thinking if we should separate a bit more. But for now, we have two big groups just to understand the type. And normally your core will be either foundational or essential, and that's something that's very, very close to the system. So the networking, the extensions to foundation, or your logging system, like things that are like very, very, very basic building blocks. And those will serve as building blocks for other cores, and so on. And the other types of cores we could have are domain, logical, or data sources. So you could say like you have four types instead of just two groups. And those will be where you start doing like the way to connect with backend, the way you do your algorithms, the way you do your business logic and flows sometimes. So for example, logging domain core will be all the rules to logging, the repository, the use cases for logging, password checks, so on. User services would be like how you connect with the user services on the backend, the API. And the experience is the flow, what you see every day in the end. So all this piece together to make a kind of a small piece of the app, or even a mini app if you have a sandbox app. And they ideally should be super self-contained and super specific, unless we get to one of the examples we will have next. So then the example is we have more than one app, and then we need to think about scopes. Sometimes you have a module that should work for confirmed, Adidas, China, retail, and so on. So you need to prepare for this. And how do we separate that? We say we have specific modules or a shared module. So when a module is shared, we think that every time you have 2 or more apps that might need that module, you should create it as shared. When you create it as shared, you have more things to think about. So for example, it needs to be stylable. The connection, the way you do navigation might not be exactly the same from app to app. So you need to have some sort of common contract between them. Those are things we are still on, like making it better and better. We didn't get to a final solution yet, but we will get there. And again, they should be self-contained. So ideally, every time you use a shared module, let's say you pass, I'm opening from app A, or I'm going to open with style A, and it should solve itself. Worst case, you get some callback, and then you handle this callback in your specific app. And the examples here are more on cores, but this also happens with any other type of module, UI and so on. And so if you see here on the folder structure, everything that's outside of a specific app is supposedly shared. Yeah. Have a small delay. Oh. Yeah. And then the other case is app specific. So app specific is when you have like a super very specific environment to develop that module. So I'd say for confirmed, the analytics has some things on top of the base analytics. So we decided, okay, base analytics is a dependency, and then we specialize that. The deep linking structure, for example, we even had a presentation about this, how we saw that our deep linking was not super good. Then we tried to use the shared solution we had before. It was also not enough. Then we extended it a bit. We created this specific deep linking structure based on the other one. And then now we'll see if it needs to go up and become shared, if we need to refactor, and so on. So this idea of specific versus shared, it also helps us to experiment. So let's say I want to try something super completely different in confirmed. I can do it. And then if that works really well, I can go and say, hey guys, let's maybe use for everyone. That's how we do it. It moves up to shared. And also, as I said, on the shared one, you need to be very, very aware of the very generic things you need to do. When you have a app-specific one, you have the possibility of not handling those cases that the other app would need to handle. Of course, sometimes you may get to a point that, okay, you built this for app A, but now I want in app B, then we need to refactor. And how it all connects, so layers. Yeah, it's not much. We try to reduce to 4, or actually 3. So we have the presentation, the domain, the data, and integration is more like a concept. So the idea is that a presentation should always consume domain, and data is always behind the domain. So first one, presentation. We have our legacy architectures, but the moment we started doing SwiftUI heavily, we tried a bit some other stuff, and we decided that TCA is a really good way to go. Of course, TCA has its own perks, own details, like we can discuss this for hours, but for us it's working super well. We don't do exactly the vanilla TCA you see, we do something on top, but it is working super well for us. So TCA, composable architecture by 0.3. And one super good point, again, before starting the data, since we have all this isolation, these ideas that you should be completely self-contained, let's say tomorrow there's another soup of letters for architecture and you want to try, you do it in your own module, you connect with the rest, and then you say, okay, I prove that this is a better option, maybe we should start moving little by little. Then we have the data. So on the data layer, what we have is mostly data models, so codables everywhere, and API services. So how you go on the backend, you decode, and you pass to the domain ideally. Or not just backend, sometimes other places. And there's a small delay. Yeah. The next one would be the domain. And on the domain is where the business rules will be. So whatever is like super close to the business, like how you do password strength, or how you do the logic like between getting from the backend, caching locally, and so on, that will be in the domain. So what we see on this domain layer, this domain box, is the use cases, which we try to represent as like super encapsulated functions. So you know that function that's not super nice to be like a big blob in your view model, you can encapsulate it as a use case. The workers are kind of not exactly the concept you see in VIP or Viper. It's just because if you start with use cases, there's a tendency to say use case A depends on B, that depends on C, and it's super messy. So we decided to call workers every time you have an entity, something that combines lots of things for more complex logic. So let's say if you need to combine 3, 4, 5 use cases to do something more complex, you're going to have a worker that may or may not just work as a proxy and connect the dots. And then it's a little bit easier to understand and not make a mess. You also have the domain models. So this can happen one by one. Domain models and repositories. I'm leaving logic controllers for last because there's a bit of detail on that. So repositories will be get from the backend, transform into a domain model, send it back. If you need to do caching, you also can do that there. And then the models, whatever comes out of the domain, it may be sometimes exactly the same as what is coming from the backend, but maybe you just remove the codable. Or sometimes, let's say you are calling 3, 4, 5 services, you can have an aggregated data thing with these 3, 4, 5s and just share what is needed, not the whole thing. So kind of a middleware BFF in the app itself. Sometimes we need to do it. And then the logic controllers, which are basically a service. So whenever you have some sort of state, so let's say the example we are using lately, shopping bag, and you need to observe the changes on shopping bag. This is like kind of tricky because it's super close to the presentation. It's also very close to the domain. It's not exactly in presentation logic. It's not purely domain logic. So we had to find a place to fit it. And we decided, okay, it's closer to the domain. It's more logical than presentation. So it's going to stay along with the use cases. And then integration, that's more like the idea of the glue code. So how do I connect all this? The main thing from all this is a dependency injection system. If you have lots of modules, there are ways to do it without it, but it's not super nice. So you need to have some sort of solution for that. Normally based on service locator, we use something based on service locator. We started using Swinject, and lately we have been moving to Swift dependencies from 0.3. And then we have the option to have the scene assemblers. This is also like kind of helper to bridge from the UI kit to SwiftUI world. And the navigation service, which is something that we were using UI kit. We're now thinking about rebuilding it. So for now, it's still UI kit, but we have some ways to also use it in SwiftUI. And the idea of experience entry point or a flow controller. So whenever you need to start an experience, you need to define how this starts, like register all routes, register deep linking, or maybe register the outputs they're gonna come out, and so on. And this may or may not be in its own place, like you could have a module for that, or you can just do it on the app itself, app delegate, go there, bootstrap. That's also possible. So how this all connects. So now we have all the boxes together. And in the end, the experiences are the big part of the thing. So you will use mostly your core UIs and external libraries, because every time we see one of those modules will probably be used by someone else. Like, for example, we have the running apps. We extract it out, and they turn into a library that's for internal use, normally using SPM. And then we also have some helpers like Twist, the build system, some specific configuration, and so on. So if you look how this all would be together, it's kind of like that. So you had this separation of all the small layers, how they will connect from one to another. Integration layer will be mostly kind of in the center because it needs to glue everything together. And then the other modules. As I said, we cannot do this with only Xcode. Xcode is good, but when you scale, it's not enough. So we have some helpers, let's say. We started with Xcode Gen, initially just to kind of break down the Xcode proj issues. And then we saw, yeah, this is not enough. We need something more robust. We need to have a better caching. So we started using Twist, which will be explained a bit later. Yeah. So now to finalize what we have been doing lately. So we built some things on top of Twist to really be able to express these concepts. So the most important part of all this is that the concepts will probably continue the same or change not much. And the way you implement them, that can change a lot. But the concept will stay the same. Like the layers should probably be the same, and the types of modules will probably be very similar. So we try to use Twist to express that, extending Twist to express that. So we have a catalog where you have the module close to the interface. You have the implementation interface, if it's a UI, if it's a core, if it's experience, and so on. We also introduced the internal modules. That's not a concept that exists in Twist. Twist just has frameworks and so on. There's also like a super nice extension to do the dependency graph evaluation, and that's one of the tools we use to check this among with other things to avoid the app to be super bad. We're working also on scaffolds, so it's not ready yet, but you should be able to say, hey, start a feature, and then you get all the scaffold. We have Danger and Sentinel. So we have Sentinel that's used for danger. So it's a set of danger rules that will also evaluate these architectural decisions and like keep the order, let's say. And we also have lots of sorcery templates to help on the day-to-day. And a good part of sorcery templates is that you can start maybe doing something just simply on the app, and then you can go and use for Twist. And yeah, that's it.
Are there any questions, ideas? comments? Yeah, you are the first.
Okay. I only have 3 questions. Do modules have ownership? So say you want to change something in a module, but it's owned by another team. So are you not allowed to change it then? Or do you have to go through change requests and wait a month before some API is implemented in a core module? Or can you do it yourself? And then
Yeah, so basically we work in a monorepo. So this is all on the monorepo structure. And for now, we don't have super specific rules because we try to talk to each other a lot. So we don't have a lot of blocks to change. What we do is like we try to be friends and say, hey, I'm going to change your module. Let's talk about it before changing. And then we try to reduce the friction. So we do pair programming and so on. So we didn't put rules. Yes, we need to add more rules, but it's working okay-ish so far.
how big is your iOS team?
Yeah.
How big? How many people?
From confirmed, we're now 6. And then for Adidas is 10?
Okay.
Okay, around 20 in total, plus the running apps that
95 that I work
have
on.
15.
So that's,
Yeah.
Okay, so that's my second question is already answered. That's good. You say you used SPM. Really?
Just for the external, the standalone libraries.
Okay.
So we use SPM, like let's say, for example, we just implemented the login system that's going to work for all apps. So everyone just goes there, pulling. The design system is completely out of the repo. So we try to keep into the repo only what's closer to the business. When it starts to get super generic, super general use, we start trying to move out.
You always build with Twist, so you don't have the problem that Xcode has that thinks that it needs to rebuild every freaking time. Okay.
Still happens.
Yeah, thank you for your presentation. And my question is about the simulators. So one of the benefits of breaking into modules is you can start up the modules by itself. And how do you also like making sure that you can, like with each module, you can actually see the UI that's in the module? Like, do you have like demo apps for different like modules so you can like plug in the different, UI components? Or do you always make sure that you have previews for Swift UI code? Like, I'm just curious of like, how do you do that?
We're still working a bit on that because we were not able to make all the features as small apps. So we basically try to rely on these contracts. And so every time we have a module, we decide, okay, do we need to get the whole thing as a dependency, or do we need just the contract and mock it? For the UI, you're just pulling the whole thing. And mostly, Rafa and George will show, you can even do that with Twist. Like you can scope into a specific part of the app with Twist, and then it kind of helps you from there. But it's also something that we're building on top. It's not 100% working, but it's getting there.
Okay, yeah. Thanks for sharing.
It works well for the external libraries.
Hello. How many applications you have, and what is your build time?
Ooh, that question will come on the next talk. They will tell you a bit more in deep about this. But we have around, I think it's Rafa, George, help me. It's 5 or 6 on the monorepo. 5. Yeah. Yeah.
I think I saw a hand somewhere. No, there's.
In the same fashion, how long does it take to run your full test suite?
Sorry?
The full test suite.
It's part of the build time. So we didn't have tests before. We're getting more and more tests. Oh, also, Rafa and George will tell you more about this. Sorry.
Okay, thanks.
Yeah.
I think it's time for a little break. Visit the bathroom or get something to drink, and then we'll meet you at 8 o'clock.
Thank you.
Thank you, Eduardo. Hello, 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 hello. No, no, no. Well, you guys can hear me? Yes. Fuck you. Well, I'm glad you all decided to stay. We've all seen that Adidas has a very large app from Eduardo. But now we have Rafael and George who will tell us how they manage it. So keep watching.
I can? Yeah. Okay. Hi, everyone. How are you doing? My name is George. And let's go to the next slide. Yeah. My name is George. I've been developing iOS applications since I can remember. I'm part of the foundation team here at Adidas with Rafa.
Yeah, my name is Rafa. also working a lot with yours in this foundation team.
Yeah.
Yeah, iOS developer as well.
Yeah.
Of course.
we're gonna talk about another important part of app development, which is build time improvements and how we are leveraging tools supplied by the community, like the amazing iOS community we have, to improve our build time. Hopefully, you learn something new, maybe get inspired, or most importantly, point out something we can improve in our system. So. Yeah. So if when we take a look at the application, the Adidas application, when we download it from the internet, it has to contain everything that is needed. A lot of files, assets, code, resources, and most importantly, translations. Think of it as a single container. When you open it, it needs to run properly. So it has to contain everything. And those things can be huge. In fact, just taking a look at the number of files we have, it shows how big it is. I mean, we have a lot of third-party libraries, but we're getting there. Ours is growing. And those files are not just there on disk. They are related to each other. They need to be compiled different ways. They need to be imported in different ways. And you know, this can be complex in Xcode because Xcode doesn't help us a lot. So let's go back to the basics. We have two important components here that constitutes an application and that we deal with on a daily basis, whether we are a pro or we just started our iOS development journey. So the target and the project. The blue box here, this is a target. And it groups resources together under one purpose, as we know. So for example here, we have the product page target that contains everything related to the product page. And we have the checkout flow target that contains everything that it needs to properly go through a correct checkout flow. Now, normally, as those grow, we tend to split them to improve speed, improve architecture. And as we see here at the bottom, we have the networking core. And this is an example of one target that we have that contains some important things we use to contact our gateway or our APIs, and this is used by multiple different targets. The second component we have, which is another one would argue that it is the most important component you have in development, is the Xcode project. And this is a project file, which is the source of truth of your entire project, and it is important to keep it clean and uncorrupted. And this can be proved to be a bit difficult when you have multiple developers working on a single project and you have multiple configurations, and even more so when you have multiple apps, because each of this Xcode project will have to reference different files, different targets, and they will have to be built differently and dependent on each other in different ways. So it could prove to be challenging to maintain a big one. So for us, for example, we have at least 3. We have one project for every app, and that is it. We went back and saw what is a target and what is a project. Back to basics, and let's see where we go from here.
Okay, so now we're gonna take a look a bit at the challenges that we are facing when working in this big application that we have. So yeah, let's take a quick look at this. So yeah, as George mentioned, okay, we have this project that we need to have to configure everything in Xcode with all the files, the targets, so everything's in there. So when only one person is working in the project, and I can imagine that most of you, if you have like personal projects, when you are the only one working on the project, everything is fine, okay? You can make your changes there and it's gonna work. When you have multiple people touching this file, it's gonna get messy super soon. And I swear that you have faced this in your project. You have multiple people working on it. And it is also something that we have experienced, that sometimes this file gets corrupted, and you have to spend like a huge amount of time going through it, because it's really difficult to to check what is going on there, because it's not that trivial, it's not a common format that other people use there. So yeah, it's an Apple thing. Then yeah, regarding the targets, and now we're gonna talk about how dependency graph. We have like two different issues. So yeah, when you think about the image, the graph that we have in the left. So yeah, usually when you want to build, like, for instance, the first node, the node A, you don't really want to build everything that is in this dependency graph. You only want to build node A, but that's not how Xcode works. It could work like that locally, but it's not going to work like that in a CI/CD environment, for instance. And even locally, if you like trust the derived data as a cache for your nodes, that's not going to also work like every single time. And there's also an additional issue, which is that in this dependency graph, and that's the second image, nothing stops you from interconnecting the different nodes and basically messing up with the build system. And this is also an issue that we experience, that we start to connect some things with other things that didn't make sense. Basically, you screw up the build times. So yeah, basically, when you are in like a building pipeline, kind of CI/CD environment, we have like this huge project that we have to load. We have like this dependency tree, which is huge as well, and that it takes quite a lot of time to build. So yeah, over 25 minutes in an M1 machine. And I'm gonna answer one of the questions that you did in the previous in Eduardo's presentation. So it's 25 minutes in total. We have like 4 different applications. We have the Adidas app, the China flavor, which is different from the Adidas app. Then we have Confirm, and we have the retail application, which is something that we use for the iPads in the stores. And that takes over 25 minutes, and it will be like maybe between 8 and 10 minutes for the Adidas app, running both the app and running the unit test and the snapshot test. Around between 6 and 8 for Confirm. China will be maybe 5, 6, and then retail is 3, maybe 2, 3. For China and retail, we don't have any tests. Yeah, that's the way it is. So yeah, if every time we have to build all this app, it takes this amount of time. It's going to take a lot of time. It's going to make the developers super sad, and of course, it's going to cost us a lot of money. When you're working in your machine, your local machine, the developer experience is going to be the same. Okay, so you have to do all these things. You have to load the project, building the dependency graph, and the only thing that we have right now, or that we know, is basically to buy more powerful laptops, and that's it. Okay, it will solve for a while. Yeah, okay. But yeah, we don't want to build. We don't want to buy laptops like each year. We don't want to buy like the new M4 whatever M5 because there is no M4, just the iPad right now. But yeah, let's take a look at the solutions, and yeah, let's see what we can do here, okay, to try to mitigate all these problems. So first, starting with the project, and this is really simple, okay? So what we can do to resolve all these conflict issues that we have, it's super easy. Don't commit this file into your repository, right? And try to generate this file. And yeah, in our case, and well, this is something that Eduardo mentioned quite a lot, we use Twist for this. So yeah, we have all the configuration right as a code, as a Swift files, and yeah, we use that to generate the project file. And this is quite important because this step of generating the the project from config files give us like the access to the dependency tree. And we are gonna build most of the solutions that we're gonna speak right now on this access to the dependency graph. So looking into the second issue that we have, which is like in this case, if you make like one single line change, you're gonna trigger like a full build, and you're gonna spend like 25 minutes waiting for a build to end. So yeah, how can we solve this? So yeah, here the idea is that, or the problem that we have is that imagine, okay, this is the Adidas app. We have the checkout and the product page, as George mentioned before. So we make a change in the checkout, for whatever reason, we need to build everything, the product page include. And the question is, well, okay, why we need to build this? Why we need to build everything? So let's try to be smart, and let's try to build only what we have changed. And this is actually what we are doing, okay? So we introduce like this caching step before generating the project. So now this will be like this. So instead of building everything, the full dependency tree, if we see that only the checkout has changed, we're not gonna build the downstream dependencies. We are only gonna build the upstream dependencies, and obviously this is gonna like save like quite a lot of time when you are building all the apps.
Yeah, but there is a small caveat about this. This only works if our dependency tree is clean, because if we link A and E together and we start linking around other dependency, then this will mess up caching. We will have a lot of cache misses, and then we would go back to square one. It doesn't matter if we have a cache, if our dependency tree isn't clean, it will not be improved. So a more concise example would be, a concrete example would be, there is nothing that would prevent a developer to import settings in checkout or checkout in settings. And I mean, they are not, from a functional perspective, they are not needed. However, someone could theoretically do that and the app would still build. However, we would increase cache misses and it messes up the dependency tree. And natively using Xcode, there is no way to do that. And but however, using the build system that we have, we can just add some assertion rules before building the project, and this will shift the errors more to the left, as in we will crash directly the build on the laptop even before we run CI, so developers are aware that hey, they imported or they used something they shouldn't, or if for some reason they pushed and didn't notice, the CI build will fail pretty fast, and we will not spend 20-30 minutes building and then to fail at the end. Again, since we have control over the project that is generated from the start, we can take advantage of that. So in terms, so scoping is another term we use to generate only what we are working on, and generating only what we need to be able to build only what we are working on. And since we have access to the build system, and since generating is just taking a bunch of files and generating an entire project, which would, even though it's cached and even though we're not going to build it entirely, it's going to still load in memory. It's going to still open in Xcode. So this is not ideal. However, since we already have a configuration files, we can use that and pick few files and just generate a scoped project. Maybe I want to work on checkout, I will generate only checkout. Maybe I want to work on a feature or experience, I will generate only that experience. So in essence, we use the same build steps. Instead of generating huge projects from many files, we just pick a few files and generate a small project, a small part of the project. Projects open way faster, use less memory, they are less heavy, and developers are way happier. I can attest to that. So let's go through an overview of the improvements we did. We removed conflict. We enforced dependency tree, which is really important. We built only what we needed, and most importantly, we load only what is needed, which is in memory when we generate a small part of the project. So, however, but what is the end result? Why did we do all of that? I mean, yeah, to make everything run faster, but for business, this is not enough. And for us, we dropped the build speed on CI by over 70%. So if you take a look at the blue graph, it is way less than the green one. Why? I mean, we didn't change the code. We haven't applied any of the improvements, any different improvements in code. I mean, we are always doing that. We are always doing what Eduardo suggested before. However, with only build time improvement, we saw 70% on average build time improvement. And the important key point here is because we are not building the entire app. We are building depending on what the developer changed. So if a developer creates a PR of only one line and a certain target that is used in one app, we only build that app, or we only build those targets. So we use the caching mechanism that we talked about, and it is a pretty huge difference. And if you are wondering why we have these spikes, these spike blue lines, those things are normal because we are going through re-architecting and refactoring a lot of parts of our code, of our core code, and essentially core code is something that is used by every app. So sometimes the entire app will have to be built, but this is normal. However, for most PRs, they are way faster. Some PRs take only 10 minutes, 8 minutes, 7 minutes, depending on the change. I'm gonna share some things we have for the future, what we're thinking about, and some side projects or side improvements we are working on. Those are still work in progress. We don't have a lot of demos for everything. One thing would be scoping. As we mentioned, that since we have configuration files and we can generate a small part of the project, our next step would be to generate an application for that. So QA and developers can quickly test and go through their changes rather than installing the entire app. The second thing we are working on is analytics, and Rafa is deeply involved in, which is we are checking whenever there is a cache miss on our build system on the CI. That's how we know, okay, this target is changing a lot. We are having a lot of cache misses. Maybe we can split it up more. Maybe there are some things that can be extracted from it that doesn't need to be there. So this is the next step. We're always working on fast testing, fast build times, and this isn't necessarily related to actual build times, but actual code improvements, separating stuff that don't need to be together, using interfaces instead of concretes whenever possible, and even more efficient development. Who doesn't like that? We're always reading, always improving, always trying to see what can we change. And the last thing I want to share is an internal CLI tool that we started using recently, and it's something that we are aiming to help as much as possible developers to interact with the project easily. Since we mentioned that we are using Twist, but we are good developers. Everyone here knows that in our apps, we usually always try to wrap and abstract any third dependency that you use. This goes as much as build improvement or generating the project as it goes in code. So we don't want our developers to be experts in Twist to be able to generate and use the project. We wrapped all of this up in a CLI tool, and we are adding additional functionalities like quickly generating new experiences. So we will go and generate all the files for the devs, generating new cores, and we will go and edit the configuration files so they don't have to learn how to use Twist, even though it is easy because it's written in Swift, but it is also an important point to mention. And that's all. Thank you for listening. I hope you have many questions for us.
Hey, normally when you start, you say that when you got here, it wasn't everything modularizer. Eduardo, I think, said that. But so when you're managing to go to more modularized and start using Twist, what is the first approach? Like, let's say you have a monolith, everything is one single file. You start with the core, and then you start growing up the twist from that. How does it work, the first approach? Yeah.
So you mean when
Going.
Yeah, the kind of like the first phase when you're getting to a modularized architecture, because before it wasn't, right? And then you
Okay.
start and grow up, start using Twist, start using other tools. The first approach is what? What do you recommend that?
So I can tell you how was this at the beginning, maybe like 5 or 6 years ago. We didn't have any target. It was just a single target, the app target. And then we say, okay, maybe we need one target or a couple of targets because we wanted to build the application also for China. And China was a different application, not the Adidas one. So say, okay, we need a shared target. And we call that mobile core. Not the brightest idea, I can say. And then other applications came to place, confirm, and we started to see that, hey, maybe we have like some functionalities that we can extract to different targets. We did that in a kind of generic way, like, okay, let's create like an UI target for the Adidas stuff. So we have Adidas UI for the core stuff, and now we have Adidas core. And that lived or worked for a while until we realized that at some point we were making like one change in one of these targets and we have to rebuild everything. And we have like a lot of files, not 10,000 files like today, but maybe 2,000 files. And at some point we say, okay, maybe it makes sense to extract or to split this split this down into experiences, or what we call experiences, which are just features. And then we came into this idea of layers, which is something like I think is common in other industries. Like, okay, you start to have like the presentation layer, the business layer, the data, then you may have third-party dependencies, so you can reuse all these components. But it's something that happened over time, not in like 1 week or 1 month. It took a while. Yeah.
And there isn't one way to split things or a set of rules to follow. In the end, you know what's there and what you can split up, and you just have to do it bit by bit. Try to split as much as you can, and whenever possible, also create target interfaces that do not change every time. That if you change the actual target, you do not build other things that depend on the interface. I hope we answered your question. I don't know if you have a follow-up.
Yeah, it did. I have a follow-up question, but that's okay. Or pass along. Okay. And how do you do the whole finance estimation? So the business part of, because I saw the graph and it's quite nice after 3 years doing this, and then you say, hey, 100,000. But when you guys starting, how do you say like we're gonna save 1 million 1 year, and how do you do the whole estimation?
No, this is actually so if I go to the graph, spanned over a couple of months, and I mean the price isn't gonna change over a couple like within 4 or 5 months. It's not gonna change within the next 4 or 5 months. So we took, let's say, 3 or 4 months, and we did it times whatever we need to get to a year, and you can pretty much know that the price per build minute. And if the project takes that much time and you do on average, let's say 5, 6, 7 PRs per day, then you can pretty much get a good estimate on that.
All right. Yeah. Thank you.
Yeah.
Okay. First, just clarify. So this is just price built to paid to the build system.
Yes, through the CI.
Oh, okay. Yeah. I was wondering whether it was like we saved 3 developers per year, or 2.
Oh.
Developers don't have to wait that long.
No, this is CI. No, we're talking about CI. The other one that is I mentioned, maybe I didn't make it clear, was the analytics one, is for developer analytics. So we also want to know how much it's taking on a developer's devices. This is kind of something we're looking forward to work on in the future. We are adding that, so we have kind of planned for it, and we're talking about it actively.
Yeah. Okay, I have another question. So you mentioned a couple of slides earlier, you have like the twist generation of your project, and then you added caching, and then you added assertions.
Yeah.
And as I understood, the caching and the assertions are stuff that you built on top of Twist.
Well, we leverage some things in Twist. So we leverage plugins for assertions to do dependency graph assertions, and caching is basically mostly Twist caching. We might be doing some things that are not 100% given by Twist, but mostly the entire thing is wrapped around Twist.
Okay. Okay, that's very nice. Do you have this written down somewhere? I mean, I'm sure Twist has success stories, but it's always nice to have like an actual story.
I don't think we do. I mean, we are in communication with the guys, but I don't think we do about this stuff, because it's tailored mostly for what we need, and some things might not be applicable for everyone, you know. And the dependency graph works. Dependency graph assertion works towards the architecture or the structure that we have. That some of it was shared by Eduardo before, you know.
Okay, so some of it is specific to your project.
Yes.
So this one only accepts this, and this.
Yes.
Okay. Okay. Thanks.
Someone else a chance?
Hi. I have a question about, so you used SPM for your third-party dependencies, and you also binary cache them?
Yes.
And how does that go, or what are your experiences with that? Is it also an expensive feature of Twist because it was paid?
Do you have an answer for that?
So you're asking about caching in
the
Twist?
binary caching of Swift packages.
The migrate caching of Swift packages. You mean binary? I heard migrate caching. Okay, binary caching. So yes, we started first with the Twist with the Twist one that was free and open source. Then there was a deprecation, and after that we have something around the deprecation and around internal caching a little bit. So it goes both ways. We are still on the old system. We have still using some of the old Twist versions, yes, and we have some stuff added from internally. So it's kind of a fusion, and obviously maybe I'm merging what you asked is whether we're gonna contribute more or release more to the Twist community. I mean, this is whenever we find there is something useful, something stable, obviously this would be the next step, right? But you don't want to introduce something that is too specific for a company that will not work, for a project, let's say, or our project, that will not work for someone else.
Yeah, but you have some kind of caching going on packages. You don't fetch the whole thing again every time you do a build, or? So
we do, but we also additionally have, let's say, how do you say, what is its name? The not JFrog, the Artifactory caching as well. So you have multiple layers of caching, whether it is downloading and then building, you know, and then all of that. All of that is working together.
Okay.
Yeah. Also something that we try is, at least in the CI/CD side, is not to just cache the binaries, but to cache the SPM folders, which kind of works and it speeds up a bit the installation of the dependencies. And then we also use the Twist cache and all this Artifactory stuff.
And if I may add something, so there is always a trade-off in caching, whether downloading is actually faster than building, you know. And since we are using for most of our builds, let's say Bitrise, so you always need to connect to your cache, and then this is over the network. So there is always a trade-off there, and we still haven't figured out when you do not have control over where your CI pipeline or CI worker runs, how to connect that efficiently over internet, not network. So there are a lot of things going on, but however, this is basically how it all works together.
Okay. Sounds really interesting.
Yeah, thank you.
One question which was not answered yet. So you how you say, check out the repo. You run your toist config thing. How long does that take to basically create the config file for the application and then build the application? Is that like the 4 minutes that is in the graph, or is it more like 8 minutes?
The total time it takes to generate the project plus build.
Yes.
So it is a bit more than 4 minutes because generating the project will be around
3, 4?
no.
Depends.
Well, depends.
You need a
Depends.
faster computer.
No, it depends. Of course.
So we're talking.
Depends.
We're talking with
Well,
with generating and downloading. So, what do you mean about generating? Just generating the project?
Yes, you have everything online. You have everything, the repo,
A minute and a half.
and you just generated. You just generated the application,
Yeah.
and then you move one commit back, and then you have to generate the application back again because someone else might have changed something. So you have to regenerate the whole project, and that's a pain in the arse.
Do you know?
Still is. So yeah. So I was wondering about
So
that.
It's a couple of minutes. I don't know how much.
Generating the project takes, if you start from scratch, it will be around 2-3 minutes because you have to download everything and then generate the project, and it takes quite some time. And then building the actual, if you are, for instance, building the app without any cache, like building just the things that we have in the repository, not third-party dependencies, will be around 4 or 5 minutes locally, M1, in an M1. And one and two.
But still is better than Xcode separate.
Yeah, it is. It is.
I have another question. So you mentioned scoping, which sounds very nice, but I can also remember from a previous project, huge project, and they said, "Oh, you just create your own little app to test your view with," but that app had slightly more dependencies. It took me like several days to just figure out which freaking modules I needed just to show this one view, because nothing was documented, of course. Well, everything was documented in the code. And they used an even better build system. So how easy is it to create a minimal viable project? So let's say Adidas asked me, yeah, we need a new Korean product page. And I think, oh, I can do that. But how easy is it to do in your application?
If it's new, fresh, I think it's pretty easy because you
fit,
decide
it has to fit in the application.
it has to fit,
Yeah.
but then you have to. I think you have to surround it by different targets that are providing it.
But if you want to like create like a scope app for something which is already in the project, it will take a while because we have exactly that problem. That we don't really know which dependency we have to use, and yeah. So that's why it is in work in progress right now.
Yeah, because you need analytics, and you need the network layer, and you need the product layer, and you need the models and stuff like that. So yeah, okay, nothing ever changes. Thank you very much.
At least they have a system. They have a system.
We are not reinventing the wheel. Yeah.
Do we have time for more questions? Yeah.
Hey, thank you for your presentation. I was wondering, what tool do you use to help you visualize your dependency graph or help you debug your caching code that you applied? Like, I changed something in module A. How do I make sure it doesn't update C, D, and E? Like,
So
how did you
you changed-
visualize it for yourself to verify the cache worked?
So currently, I don't think we have something like that. We know what are the dependency because they are clearly described in the configuration. However, do you think this is one of the things that is visible in Axiometric for us?
Not right now.
Not yet.
Yeah.
Not yet. We don't have that yet.
Cool, thanks.
Were there more questions, comments, ideas? No? Then thank you very much for the talk. Also, Adidas, thanks for having us tonight. please be so kind as to clean up your bottles when you go home, because that will be nice. And please move to this side. More instructions. And enjoy the rest of the evening, and hopefully we'll see you next time at ABN.
Nice.